All right, guys. So the topic today is networking hardware, and I'm going to follow this on the perspective of the book that we have, and I'm going to follow this topic in the same order that the book is doing it. So after the that we, covered the different types of technologies for connection in terms of the medium, then we need to know what the different hardware devices that make possible networking and connections to the internet and how they work. So let's just work on this based on this scenario. So let's say that I'm describing part of the network that we have at BNDS, or part of the network that we have at the building where we usually have class. The first part of this is going to explain how, for example, the mobile devices work. So usually what you have is, even if it's your laptop or your mobile phone, each one of those devices internally has a circuit that is called a network interface card. This circuit is the one that allows you to connect to either using wire, connecting to the switches, or using a UTP wire. That's how you connect. You have a internal circuit called network interface cards that takes the signals from that wire and um, I don't know, it takes that information and uploads that to the buffer, or the place in the computer where that information is stored to be processed by the CPU. And even if it's a mobile device, then you also have the circuit, which is a wireless NIC, or wireless network interface card, that also takes those signals, those bits that are sent through electromagnetic waves, and then transforms that internally into digital information that is sent to a buffer and then to the CPU for processing. So that's part of the hardware that you need to use. Now, this NIC is explained in the last section, but I wanted to just explain it first, because that's actually what allows all the different devices, or the different computing systems, to access networks. Now, after that, think about that NIC that connects either wirelessly or using wire to other devices. We can say that it's like the first step of the connections in the networking. Now, if it's Wi-Fi or if it's Bluetooth, you should have another device that is an antenna, right? Or it has an antenna inside. Now, if it's Wi-Fi, their antenna is usually one device that we call an access point, and this access point is responsible for getting all the electromagnetic waves sent from devices and to send information to those devices through these signals. Now, this device should be connected using a wire to what we call a switch. Now, in the old days, the switches were not switches, they were called hubs. So the hubs had a different behavior. So what a switch would do is just create internally a path between all the connections that it has. For example, if I needed to connect these two computers, it would create a link between these two. Or if I needed to connect this first computer with the last connection here, then it would create a path electronically to connect those two and isolate the communication between these two ports. Now, the hub would not do that. What the hub would do would be to just any signal that it receives, it would send it to any other port that it had here. So if this was a hub, then if I, for example, get here on this wire a 1010, then that 1010 would be sent to any other devices connected to this hub. Now, that's very inconvenient because obviously you have a lot of traffic and you're going to have collisions. So whenever the two different devices want to send information, then they first need to check if the medium is used or not. or if the hub is in use or not. In many other problems where you were trying to send multiple signals at the same time. So obviously the use of the medium would be more crowded, and this was just not very efficient. So then they created the switches that allows us to have specific routes between the different endpoints where the communication is being sent. Now, let's say that, for example, from this access point, I receive all the information from these devices, the PC, the laptop, and the phone, and then it sends all that information through this wire. And let's say that I'm going to send that to this PC. So what it's going to do is going to map these two ports using the MAC addresses for this device and for this device. They all have, I mean, any device that is connected to a switch is going to have a MAC address, because the MAC addresses are embedded or are identifying these network cards, right? These NICs. And any device that connects to a network should have a NIC. So if you have a NIC, then you have a MAC address, and if you have a MAC address, you can connect to a switch, and the switch can create paths between those two devices identified with each MAC address. So that's what a switch and a hub does. It's actually just connecting different devices, and it's also used for distribution of the connections that are incoming. For example, if we just look in a higher perspective or in a bigger perspective, let's say that this router is I'm going to explain what that is, but this is the device that is receiving all the information from the internet. Then if I just take it this way, right, through the bridge and to the switch, then I'm going to be distributing the signal or the services that are being accessed by this router, and it's going to spread that through the whole network that we have here. In this case, it would be the building one network. Now, there is another device that is called a bridge, and what this bridge does is just connecting to different LANs, for example. So let's say that I have another switch in the cafeteria, because I don't know, the cafeteria is new. So let's say that this is a new part of the building. So they build all the walls and all the things from the building perspective, and then they want to provide Wi-Fi and connections to those computers there. So they would probably install one switch or one additional switch here. And let's say that I want to make sure that all these two buildings, I mean the cafeteria and the building one, are seen just as one. So that's how we can make use of this bridge. The bridge would be the device that would be joining or assembling these two different networks, right? But the good thing about, the one thing about the bridge is that it should use the same protocol. So the protocol that I get from this wire, from this switch, should be the same protocol that I get through this wire. So it's usually for wires is Ethernet, if we're talking about UTP wires. So the bridge is going to do that. It's just going to join two different networks, all right? So I was talking about the switch. So usually what you have, let's say in a building, in each floor, you're going to have one or more switches depending on the number of ports that you need. And usually, for example, the data center, which is where you have all the servers, each one of those computers that you have there should have an interface card as well, a NIC that is connecting them to the internet and all the other services. So usually what you have is a switch or more switches that receive the communications of those computers or those servers in the data center, and it would connect this with any other switches in the building. And usually that those switches would be joined using things like fiber optics or things like that, so the communication between switches is very fast. So maybe you could have this for one floor, and I mean this could be um, the switch for one floor. This could be, I don't know, floor 2. Right, and this could be floor 1, assuming that the servers are in floor 2. And that's how you can distribute signal in a very fast manner, because this Ethernet protocol in the wired connections is very fast compared to Wi-Fi. And then if you need Wi-Fi, what you could do is just connect to the switches access points, right? And these access points then would give access to any other mobile device, right? Now, the device that is giving us real access to other networks is called a gateway. So the gateway is going to be a device that takes all the traffic from this LAN, for example, the building 1 LAN, right? The one that we have here. This is building 1 LAN. And this dashed line is explaining like where's the boundary of that. So if we connect a gateway there, then this device would be the way that we can connect to other types of networks. So let's say that, for example, all the building 1 network, instead of having a connection through Unicom, it would have a connection through satellite. Let's say that this is, I don't know, the building that is far away. So if we want to translate from this Ethernet wire that we have here, right, this Ethernet, to a fiber optics channel, then what you would need is a gateway, because the gateway is able to translate all the incoming connection data and connections from this point, and it's going to translate it to the protocol that you use in the other connection. So here I'm going to have the fiber optics, so the gateway is going to be able to just take those packages of information and the data and the bits and bytes, and it's going to transform them so they can be traveling through this medium. Now, you can even configure multiple gateways. Let's say that I don't know, I want this mobile phone to use this satellite connection. So I could say that the gateway could be this, and then this gateway would connect to this router, which I'm going to explain later, and it would connect to an antenna, and this antenna would be connected to a repeater, and this repeater would be connected to a satellite. So that could be one of the exit routes for this computer or this phone. Now let's say that I want this laptop to have a different type of connection, and I could use, for example, to tell this computer to send it to this gateway, right? That the default gateway for this device is not going to be the first gateway, but it's going to be this. And this one could be connecting, for example, Ethernet to coaxial. And this coaxial could be connected to a modem that would connect to what it's known as the public switch telephone network. Now, the advantage of that would be that you could use very old infrastructure and cheap infrastructure of telecommunications like the public switch telephone network to send information. Now, you would need a modem for sure, because here you would be receiving information in digital form, right? And to send it through telephone, you would have to make that a voice, right? So you would have to make this an analog signal. So that's exactly what the modem does. It's going to take digital signals and it's going to transform them into analog signals to be sent through the telephone networks. Now, that could be the case, but this is very unlikely to be nowadays, because usually now all the networks don't work on copper, for example. They work on fiber optics. So maybe you're not going to need a modem. What you're going to need is router gateway. So a router gateway is just one device that has both jobs. It has the gateway job, which is to provide an exit way to all the communications and to translate from this, for example, Ethernet to fiber optics. But it's also going to route the information. Now, when I say router, when I talk about route, it means that the information that it gets here, for example, let's talk about the same 1010, or well, actually it's going to be a package which is going to have a lot more bits and bytes. This package needs to get to a specific destination that is identified by an IP address. Now this router guy is going to determine what's the route to get to that specific IP address. So let's say that this is now accessing directly to the internet through the ISP, through the internet service provider. And if you were to look at the internet, what it would be is just a bunch of routers connected together. So different networks to get connected together. Now, each one of those routers has the capacity of routing dynamically the packages that are being sent. So if I am, let's say that I have this data, right? And this data has to be sent to a specific IP address, like, I don't know, 172.60.1.2. And I have that IP address, I don't know, over here. This is the IP address where I need to send it to. So this is going to have 172.60.1.2, which is going to be the gateway for another network, right? So I'm going to have another network here. And this router is going to be the gateway for that. It's going to be a router and a gateway. So whenever the package is sent, after it gets to this point, then this router is going to say, okay, I think the best route for that is going to be this, right? But once it sends it to the next point in the chain, so maybe this, when it gets to this router, then this is going to try and recalculate the route. So it's going to say, okay, you thought this was the best route, but I think that since this link is not working very well, I'm going to send it this way. And then this one is going to recalculate, and it's going to say, okay, this is the fastest route. And then this one is going to recalculate and going to say, okay, this is the fastest route, and this one is going to recalculate and maybe send it here, okay? So the routing is happening at the moment where the package is being sent. And that's what routers do, and that's the main difference with the gateway. So a router is going to be able to route the packages through their network. The router is also going to translate information from one protocol to another, and so it's going to be a default gateway as well. But the main difference is that the router can route, and the gateways cannot. Gateways can just take from one protocol and send it to the others, just like we saw here. So maybe taking from Ethernet to coaxial, or taking from Ethernet to fiber optics. So that's what gateway would do, right? It's also what a router could do if it has that functionality, but the router, it's going to be calculating the route to get to the other routers. Now, we could think that the other device that we need to talk about is the repeater, but just to follow with this example, let's say that this repeater thing, or this repeater device, is going to be a wireless repeater device. So that means that it's going to receive any signal that is being sent to it, and it's just going to grab that signal and is not even going to think about it. It's going to retransmit that. Now, for example, for satellite communications, you could have repeaters, or you can just have an antenna that sends it directly to it. But for some regions and for some places where the communication is not easy, then you might have to use these repeaters that just take the signal in, and they're going to boost it up, right? Make it bigger, and then send it to any other place or any other destination, like, for example, a satellite. And the satellites, when they are up there, they just receive information from the ground and retransmit it to another place on the ground. So um, that's actually how satellite internet works. You just put an antenna, then it's sent to the satellite, which is going to send that specific information to another antenna that is at some point sent to a router, and it's going to be part of what we call the internet, right? So we can have access to it. So I would say that that's it. So the different devices that we checked today were the NIC, the network interface card, wireless NIC or just NIC. So wireless is for just wireless technologies. The access point, the switches and the hub, the bridges, the gateways, and the routers. So that would pretty much cover all the different devices that we have in the book. This section that I'm talking about is section 216. And with that information, you should be able to understand what they are and what they could do and what they could do not do. I mean, what they are not able to do. At the end of this section, you have one comparison chart between routers and gateways. So please take a look at that. And you should also be able to look at the wireless, the network interface card section and the wireless network interface card, which explain a little bit how, I mean, it's 2 or 3 paragraphs about how they work. That's it for today. Next video is going to be about the use of Ethernet in these networks and how they implement some specific protocols like CSMA CD to avoid collisions. And with that and the bit streaming topic, we're going to be done with this first section of the chapter. Then we're going to try to explain how the internet works and in this next section, and explain a little bit more what the PSTN is, and then we're going to talk about IP addressing, which is a long topic and a big topic. That's going to be maybe after the Golden Week. All right, guys, so I think that's it. Please, after watching the video, just read the section so you can have more information about these devices. And I'll see you in the next session. Take care. Bye-bye.